Hello, my name is Geir Davidsen. I'm an associate professor working at the University in Tromsø in Norway. I'm here at Karma as a guest scholar this autumn, and I have been working together with Wright, sitting beside me here, on one of my pet projects. It's called the self-playing Euphonium Mouthpiece. I am a Euphonium player, as you might imagine, and I have been playing professionally for like 25-30 years and specialized in contemporary music. My PhD has been in performing arts, and I have commissioned a lot of works, especially from Norwegian contemporary composers, that has made use of a lot of extended playing techniques. Many of those composers has also been into electronic music, and I often found myself in environments where we were exploring like the surround possibilities of a euphonium player and surround electronics. In many cases, I have also been like, when I've been playing with live electronics, much of my euphonium playing has been channeled out to loudspeakers. I've been thinking about why not change the loudspeakers with self-playing euphoniums instead. To do that, I actually have built some prototypes before I came here, and I will show you one of those. When I say I have built it, it's an exaggeration, I would say. I have glued two components together. This is a regular trombone and euphonium mouthpiece. This is just a Bluetooth speaker, relatively cheap one. It's closed, and all the sound comes out just one way, and that's through the mouthpiece. I can demonstrate it by just playing and recording of myself. So this is myself playing the euphonium, and it's now coming out of this euphonium. Okay, so that's quite a lot of fun. Maybe it sounds, it resembles the euphonium sound quite well. It's a fun thing to do. It's a bit soft, and the sound is kind of thin, maybe. So when I put this setup in a concert hall, it disappears too much, and that's a problem. So I've been thinking about building a kind of a stronger type, maybe actually building a mouthpiece with parts in it that would do a better job of transporting sound out to the audience. And by that also kind of building several of them, so I can set up like 6 to 8 or maybe more euphoniums and tubas playing together with me in an ensemble. I was not sure how to go forward with this, because I know this sounds good, but it's soft. What kind of approach would we do to manage to build something that's better? And Matt here has been helping me a lot, and he has been building also a form for 3D printing. Maybe you could say something about that. Yeah?
Sure. Well, do you want to tell the drum story?
Yeah, we can do that. Yeah, we can do that also.
So we made some prototypes using this kind of a surface transducer. So this is a product that's made to just sit on a tabletop, and you put the signal into it, and this little piston vibrates in and out, and then it vibrates the whole surface. So we thought, well, if we suspended one of these, if we just put one of these right up to the mouthpiece, it's just going to be pushing back and forth on the entire instrument, which is not what we want. We wanted to have a sort of some kind of a thing that it could actuate that would make the sound and then push the sound into the mouthpiece. So we were doing some experiments, and we found if we put this on a drum head, then it very much amplified the sound. And so we built some simulated drum heads. So here's just a kitchen funnel with some moving tape, some just clear plastic tape, and it makes a very, very bad, very poorly tuned drum. But even so, when we put this on it, and if we held it just right and we got it right in the center, we could get a good amount of sound, and then if we plug this in.
Yeah.
Do you think we're going
I
to
can
actually try this?
demonstrate it,
Okay,
yes,
please.
Yes. So just plug this in and play the same clip as you heard on this mouthpiece. Just hold it here, maybe.
Yeah. So one fun thing about this is that if the connection isn't solid enough, then there's a little bit of a buzzing. So you get that sort of distorted sound that's kind of like overblowing on a brass instrument. So that was one of the intriguing aspects of this project is the similarity in sound, very, very different acoustic production mechanisms, but that. So then we built a series of various drums.
Yeah. So this is the material here is packing tape and what do you call it?
Paper vellum.
Paper vellum. It's a combination, and it sounds louder and better. Darker. Okay.
So our thought was, let's make a cross between a drum and a euphonium mouthpiece. So it's a piece we called the funnel. So the idea is that there's a very mildly tapering section here that can go into the lead pipe of the instrument, just like a mouthpiece. And then some kind of a way that it will get out so that we can have a larger diameter to accommodate the actuator. And then we were going to basically make a drum head over the surface of it, again with the same vellum and packing tape mechanism. So we built that.
Yep.
It was somewhat successful.
Yeah. The problem is that it really did not transport the sound so efficiently into the instrument, in a way. If I touch those, I think you can hear something out of the instrument. We made a better version, but still, this is... Okay. So some sound might maybe come out of the instrument, but mostly is here around the drum head. So it's quite a good construction of making some quite good sound here, but not tunneling it further into the instrument.
Right.
Yeah.
So then the next idea was to put a cap over it, so that we could just mechanically, prevent the sound from getting out, and sort of hoping that it would force all of the sound down into the instrument. So that's what this part is. And then the idea was that on the inside we would have this membrane, we would glue the actuator to the membrane, and then we would close the whole thing so that the energy would all have to go into the instrument.
Yeah, yeah. We tried that, but with not 100% luck, I would say.
Yeah.
Right?
Agreed.
So, to take it a bit further, I was thinking what about just putting a loudspeaker inside this thing? Do you have it here?
Yeah. So here's the 3D
Yeah.
part. So I did all the 3D design using a piece of software called OpenSCAD, which unlike most 3D design software is all done with a sort of programming language text interface. So here I am setting that the thickness is going to be 2 millimeters and the height of the first section is going to be 45 millimeters and the various diameters of the sections have a certain size, and then I compute some other variables based on these variables. So the interior at diameter 1 is the exterior diameter 1 minus 2 millimeters, etc., etc. And then I just define the shape based on cylinders that are moved and translated in different ways. And then I take the difference between that and an interior shape that gets cut out. So I build it, so for example, I could turn off the interior shape that gets cut out and re-render, and now you just see a solid chunk with the one conical section, the two conical section, and the cylinder here. And now it's completely solid, and then if I just uncomment that piece, then now it's carving out this interior part and also the 4 holes that we screw it through. And so this program will output an STL file, and then we can load that into another program that turns it into instructions for our 3D printer.
Yeah. So for the further steps, we used the cap. Could you put up the cap also? Originally, the cap was. We thought the cap was going to have this transducer inside the cap, right? Inside this cap, the transducer should be, and then we had the membrane just in front of the funnel. That was the thing. But instead, we now have put a relatively small speaker, but it's a full tone speaker inside it. And between the cap and the funnel, we have made one small plate sheet, that between here, and we have drilled a hole in the middle of it that matches the exact diameter of the loudspeaker, and by that we are making a seal between the loudspeaker and the funnel. And then we have the effect of pushing quite a lot of energy back and forth from this part of the mouthpiece, and then we get relatively high sound, at least. Should we just demonstrate it?
Sure.
Yeah. So the same thing now played with a newer version. This is still a work in progress, so there are quite a lot of distortion, but maybe you get a sense of how loud it is. Okay.
So from here, that's about 83 dB SPL.
Yeah.
So maybe we could go back to the original design and try it again, and hopefully we'll see a number that's less than 83, and we'll know that we
hopefully
quantitatively succeeded during your visit here.
Yeah. Oh. See?
I don't know if this is visible. So it looked like it was mostly around 73 or so, which goes with what I'm hearing, about a 10 dB increase in volume.
Yeah, that sounds probable. Yeah.
Karma, where louder is always better.
Yeah. So there are some issues now still, because the sound can be more clear. It's kind of it's clouded in a way, but so it can be clearer. And we have some issues with that it's distorted. The two things we are going to explore now is what kind of loudspeaker should be placed in this. The things we have been using now are low level, kind of cheap loudspeakers. We are going to try something more high end. And the other thing is the shape inside the funnel. How the thing that this thing actually works quite well. This small little thing. We think it has something to do with the shape of the inside of the mouthpiece. The funnel we have been making now are not a cup, it's just a regular straight form funnel, right?
Yeah, the inside is just a cone.
Cone, yeah, inside is just a cone, yeah.
Oops, sorry, let me show that. So this interior part, these walls are all just conical.
Yeah. Inside the mouthpiece, a brass mouthpiece, it's more like a cup. It's actually two cups. It's a large one and a small one going into the smallest part before it expands again. And this thing we might consider at least making a version of for this mouthpiece. Yeah. Okay. The use of this thing can be more than just making this my self-playing tuba orchestra. We have already just been starting exploring different things, and Christopher
Jetty
was here making just a small max patch for a piece he is thinking about. He is actually thinking about setting the air column in motion instead of doing a playback of the euphonium. So this is just pulses. Yeah, it's just simple pulses going into the instrument, and I can use the valves and actually play different frequencies.